Good day, good day, good day, good day, good day. I hope you guys are good. I really hope you guys are good. Just type on the comment section so that we know where are you watching us from, so that we can start right now in the preparation for the test which you guys are writing tomorrow, right? Which is maths paper 2. Welcome to YeboTutor Livestream Help, and I hope people are ready to prepare for tomorrow's test. So you can see we're going to use like a previous test which was written last year from Gauteng. Then we're going to use that as one of the questions which we're going to be using to practice for our test. All right, just text on the comment section so that we can see where are you watching us from, please. So that we know where are you watching. All right, let's look into our paper 2, which is a beautiful paper which is only 150 marks, which has only 3 topics which are always straight to the point. So we are, as always, you know that we have our statistics paper which is 20 marks. Those are the first 20 marks which you can expect in your statistics. So yeah, the question for the statistics is usually easy. We'll get back to that one. Let's start with the proper hard questions. All right, here we go, and here we go. Question number 3. Yes, in the diagram below, we're starting right now. In the diagram below, point P, which is given as 9:12, point Q, which is 9:9, and R are vertices of the triangle PQR. Let's see where are these points in this triangle which they are speaking about, so that at least we can be aware of what we are dealing with and what we are looking at. So we can see that these points which we have here, this is the point P here, this is the point Q, this is the point R. So we can literally see that that's forming the triangle which they are speaking about over there. Then of course they say that also M is the midpoint of QR. Okay, that's beautiful. Where is QR? Here is QR, and M is the midpoint, which means we can calculate using the midpoint formula. So we are analyzing the question before we even answer. And NAB is a point on PB, which means this point N here is under this specific point, which is on PM in the second quadrant. The equation of QR is given by this. Oh, okay. So which means we are given the equation of QR. Then now the angle of inclination of QR is theta, as you can see here. Now the first question goes and says that calculate the coordinates of M, the x-intercept of the line PM. They want the x-coordinate of the line PM. This is not that bad. We are given the equation, right? And we can see that M is on the x-coordinate, which means M is always x, comma, 0. And we are given the equation of the line of QR. In this instance, is given as 2y minus that. So we can now write 2y minus 3x plus 9 is equal to 0. And we know that at point M, its x is to 0, which means your y is equal to 0. So that will be 2 times 0 minus 3x plus 9 equal to 0. Then negative 3x is equal to negative 9 divided by negative 3 divided by negative 3. Then now you end up having your x, which is equal to positive. Your x will now be equal to positive 3. All right, so that will be your x over there. So which means the coordinates of M will be M, which is 3:0. Easy stuff. Then you are done. Then now we can proceed to the next question which we have in this instance. So when you're looking at the second question which we have in this instance, now we are being asked to determine the equation of PM in the form y equal to mx plus c. And how much is that? 4 marks. Let's see PM. So PM is this line PM. We know the coordinates of M, which means we can be able to calculate the gradient of the line PM. Then we can be able to find the answer. Alternatively as well, we can also be able to do that because we already know that this is your 3:0 as M, and we also have that. So we can calculate the gradient of line PM. So we know that the gradient of PM will be equal to your y2 minus your y1 over x2 minus x1, which is equal to what? What is the coordinates of point P? This is given as negative 9:12. So let's write that down so that we don't forget. So P is negative 9:12, and M is your 3:0. So that can be 0 minus 12, 0 minus 12 divided by 3 minus 9. Then of course you get your gradient over there, because that would be your gradient there, and your gradient is going to be equal to negative 1 there. So now that we have the gradient, we know that we have the equation y minus y1 is equal to mx minus x1. So we can even use the point M, which is 3:0 over there. So that will be y minus 0 is equal to -1 because the gradient have calculated it here. So that'll be -1 multiplied by x minus, and your x is 3 over there. So now y is equal to -x plus 3. So which means the equation of that line is equal to x -x plus 3. That's already easy because we already calculated other values perhaps, which we also wanted to deal with when we are solving this specific exact question which we have. So there's no way no one could have been able to get that answer, because that answer is quite straightforward from what we have already solved in this specific time and moment. Now let's proceed now and see if we cannot go further and solve our question right. Now let's go to question 3.3. Now they're saying that calculate the size of theta. What is theta? We can see that theta is a side which is available over there, and theta is on this specific angle. And where is this angle? This angle is on QR. So this is now making our life a bit easy, because we know that this is where QR is. So we can now be able to solve our problem because we know where QR is. So with that, without wasting much time, now we can now be able to solve our problem, which is on 3.3. We know that we are given the equation of line QR to be 2y minus, let's go back there, it's 2y minus 3x plus 9, 2y minus 3x plus 9 equal to 0. So this is the same as 2y is equal to 3x minus 9. You divide that by 2, divide all through by 2, then your equation is y equal to 3 over 2x minus 9. So we can see that our gradient of that line is 3 over 2, and we know that the angle of inclination is always tan theta is equal to the gradient. So which means now we can now be able to find theta, because theta will now be the arctan of the gradient, and the gradient is 3 over 2. So your gradient now, with that being said, will now be equal to what? Using your calculator, I am getting 56,31 degrees. Okay, so that will be our angle there. Just like that, you are good to go, and you can be able to find the solution to your problem. You see, maths is so easy and so nice, guys. So don't worry, I got you. I got you, guys. Now, proceeding to the next question. Now, we can see that on the next question, they say that show that B is equal to -3 minus A if P, N, and M are collinear. What does the word collinear means? That's where the trick is. We need to understand what is a collinear point and how do we see a collinear point, which means that this is already easy because we already know the equation of line PM, and the equation of line PM is y equal to -x plus 3. This is already easy. How can we show that B is equal to that? We can show that B is equal to that because we can now substitute the point, which is A is to B. Just like that. So B now will be equal to -a plus 3. Then of course we can now make your B the subject of the formula, and you can now see that your B is the same as your 3 minus A, just as what they showed us. So it's easy. That's why it's 1 mark. Collinear points, which means they are in the same line, which means we're going to have the same gradient with that specific points, and they're going to have the same equation as well. So that's not hard at all. Now 3.5, hence determine the values of A and B. Okay, if NQ is equal to 5 root of 5 units. Okay, guys, if you still remember, we know how to find the distance. We know that the distance between 2 points in distance of the NQ will be equal to square root of x2 minus x1 squared plus your y2 minus y1 all squared. Okay, so of course if we remove that, which means now we now have to square both sides. We square both sides so that we can be able to remove that. So the distance of NQ now will be now squared equal to your x2 minus x1. We square that plus your y2 minus your y1. Again, we square that as well. So now our life is equal to easy because we're already here above here. The moment they say hence, which means use what you have already above. So we know that our y there, our B is equal to your 3 minus A. So since we know that, now we can now be able to do what we want to do and solve any question because we know what's happening and what's cooking over there. So this is now the same as going to be as your 5 root of 5. Then we square that, of course, equal to your A minus your 9, okay, plus your B minus your 9 again. Then we square that, of course, but our B here, we know that our B is equal to 3 minus A. So from that point now, we can now be able to see that, okay, our life is already easy because we know what is the value of B. So since we know the value of B, then now we can now be able to solve that. So that will be now 5 root of 5 squared is equal to A minus 9. Of course, this is 2 squared, 9 squared, of course, plus then your B is your 3 minus A minus 9. Then we square that as well. So after that, we know that 5 root of 5, that will just be 5 to the power 2, which is 25. 25 times 5, that's 125. So we have 125 here, which is equal to a minus 9 squared. That will give us something which is beautiful, which is your a squared minus your negative 18a plus your 81. Of course, we know that a minus 9, we multiply that with a minus 9, that will be a times a. That's a squared, a times that, negative 9a, and plus 81 over there. The negative 9 minus 9 is giving us that negative 18. So that's where negative 18 is coming from. Then, of course, we now have plus your a minus 6. Then, of course, we can see that that needs to be negative a minus 6, and we square that. Then from that point now, we can now be able to solve, because it's still 125, which is equal to your a squared minus 18a plus 81. Then, of course, now we need to remove the brackets. So when we remove the brackets there, that will be negative a minus 6 multiplied by negative a minus 6. Then, of course, negative a is positive a squared. Then you have a positive a 6a. Positive 6a, of course, positive 36 over the 6 times 6 is 36. So that will be plus your a squared plus your 12a plus your 36. Then from there, your life is already easy. Why is your life easy? Because we already know that we have already removed all the brackets. Now we're just adding the like term. So that 125 will be equal to a squared plus a squared. That will be 2a squared negative 18a plus 12a. That will give us 12 minus that. So that will give us negative 6a. Then 36 and 81. We add those two. 36 plus 81. That will give us 117, which is positive. Then, of course, we transport this 25 there. That will now be 2 a squared minus 6a. Then 117 minus 125, it's negative 8. Then from that point, we can see that if we divide all through by 2, that will give us 0 is equal to a squared minus 3a minus 4. Then, of course, from this point, we can now be able to find the simple factors, because the factors now will just be your 0 is equal to your a minus 4 and a plus 3. Is it? No, it should be plus 1. Yes, 1 minus 4 is negative 3. Negative 4 times 1 is negative 4. Perfect. Then you now have your a to be equal to 4, or your a is equal to negative 1. Guys, please don't forget, if you don't know at this point how to find the factors when you are here, you can still use your x is equal to negative b plus or minus square root of b squared minus 4ac over 2a, so that you can be able to get the value. So you can still use that specific formula so that you can be able to find the values of your x, which will be in this instance your 2a value. This is a and another a. At this point, bear in mind that we want to look for the values of a and b, and from the diagram which we're given, you can see this is a and b, and you can see that a is in the second quadrant, which is in the negative side, which means now we need to conclude, right? Because we can see that our a is in the second negative side of x, since we got two values 4 and negative 1, which means that we can now conclude that then therefore n will now have that a to be negative 1 is to be now. Why? Because we know that the a value should be negative. So the a value which we got from the two values should be negative. Now we need to find the value of b. How is it not easy for us to find the value of b when we already know our equation over there? What is our equation saying? We know that our equation is, let's change marker over there. Let's use this one now. So we can see that our equation is y is equal to negative x plus 3. And of course, we know that when we substituted with that specific equation which we had there, we say that this will give us b, which is equal to 3 minus a. And what is our a? Our a is negative 1 over there. So that will be b is equal to 3 minus 1. Then you get your b, which is equal to positive 4. So then, therefore, now we can conclude that the coordinates of n is negative 1 is to 4. Then that's just like that. You see, your life is already easy. Then that's how we can be able to solve that. That's easy and straightforward, because we know how to apply the equations which we are given. Now let's look at 3.6, because we are writing this as a test, guys, so we need to be prompt when it comes to time. We need to make sure that we are on par with what we are doing. Now, determine the equation of the circle centered at O. O is the center, the origin, and passing through point R. Okay, that's easy already, because we can now be able to find the coordinates of R. How do we find the coordinates of R? We can see that we have the midpoint formula. So that will give us a proper stuff, because we know that midpoint formula is xm is equal to x1 plus x2 over 2. And of course, we can have your ym, which is equal to y1 plus y2 over 2. So we can now be able to find the coordinates of R there. So that can be 3 is equal to your 9 plus x, as you can see here from our diagram. Here's the point which we already have the coordinates of m, and the coordinates of m is 3 is to 0. So we can now use our equation which we are speaking about, that we have xm for the midpoint and ym for the midpoint as well. So that will make our life more easier, and we can be able to solve and find the values of r. So I wanted you guys to see this specific range. All right, so we can now use the coordinates of q and the midpoint so that we can be able to get the values of r. So that's why I'm saying that oh my word. So here is it. Xm is equal to x1 plus x2 divided by 2, and ym is equal to y1 plus y2 divided by 2. Now from that point, now we can now be able to solve the problem, because now we know that this is 9 plus x. We divide that by 2, and of course another value for the midpoint was 0. So it's now coming for the ym. So that will now give us your 0 is equal to your again we have another value 9 plus y. We divide that by 2. Then of course when we cross multiply, this will be 6 equal to 9 plus x. Then of course this will be 0 equal to 9 plus y. Then of course we can see that 6 minus 9 is negative 3 equal to x. Then of course we can also see that y is equal to negative 9. So we can see that our coordinates are here. It's easy already, because we can see that the coordinates of r here will be equal to negative 3 is to negative 9. The equation say that find the equation of the circle having its center at O, which means this is at the origin. So when it's at the origin, we know that it's x squared plus y squared equal to r squared. So we just need to find the radius squared. So how do we find that when we already know the point? Negative 3 and negative 9 on the circumference. This is already easy, because this is now negative 3 squared plus your negative 9 squared. Then that will give us your r squared over there. 3 squared is equal to 9. 9 squared is equal to 81. 81 plus 9 is equal to 90. Don't try this at home. Use your calculator, because tomorrow you only have 3 hours to finish this, and you can need to get a distinction on that. So we can see that our r squared is equal to 90. Then from therefore you can now conclude that the equation of this specific circle having a center at the origin passing through the point r will be equal to x squared plus your y squared equal to 90, because 90 is your r squared. All right, then of course your life will be lekker. Next question. The acute angle between the lines QR and the line with the equation y equal to mx plus 4 is 45 degrees. Ooh, all right. Determine the possible values of m. All right. So we can see that the angle B, let's go back to the diagram so that at least we can be able to see what we are speaking about. All right. So from the diagram, let's clear everything over there so that our diagram can be a bit clearer, and you can be able to see what devil are we working with. All right, so they're saying that this line, they have an angle of inclination which we can have there, and we have the equation which are given that it's y equal to, okay, so the acute angle between the lines QR, okay, and the lines of this equation which we have mx plus 4 is 45 degrees. Now we need to find the possible values of m, or the possible values of the gradient. So we can see that we are given our y, which is equal to your mx plus 4, right? Then of course we can see that when we calculated the angle there, we calculated our angle, and our angle was 56.31. So here's our angle which we calculated there. This is for the QR which we had. So we can say that this new angle, maybe let's say it's beta or alpha. So this new angle there which we have now, it will be now beta is equal to that 56 which we had 0.31, and we subtract that 45 degrees, okay, so that we can be able to at least get the value of beta there. Then our beta there will be 11.31 degrees, okay. Then from that point now we can find the value of m, because we already know that the tan of this angle beta will give us the gradient. Then tan of 11.31 degrees is equal to the gradient. Use your calculator on your side. I'm also using mine on my side, and on my side I am getting my m to be equal to 0.20. Okay, so that's my first values. They say that the values of m, that's my first value of a. So if we can now add, because we don't know which side is this angle at, so if we can now say that, okay, the first criteria, we used the beta there, then we divided that and subtracted that, we can see that we're getting this. Now we need to find another one which we are now adding now, okay. So now that will be your beta again, we can be equal to your 56.31 degrees. Now we are adding that angle 45 degrees, so that we can be able to at least get that other angle which we have there. Then that will give you 101.31 degrees. So now that we have this again, we know that tan theta is equal to the gradient. So tan of 101.31 is equal to the gradient. Then using your calculator, your gradient is, don't try this at home, don't try to use your head, use your calculator. Your calculator is here to help you and make sure that you ace this exam which you're writing tomorrow, right? So please make sure that you do that so that at least your life will be much better and easier. So your angle M there, which you are given there, your M will now be equal to -5, okay, using my calculator. So we can now see that we have two values. We have -5 and 0,20. So those are the two possible values which we can at least get in this instance, which we are playing around with. Okay, so if I'm plotting this so that at least people can be able to see what is Vuyani speaking about, so let's plot it so that at least people can have an imaginary view of what I was speaking about and what I was calculating here. So we can see that we can have something, of course. Here we go. Okay, that's not nice. Here we go. Then of course we are having our points there, so maybe we can just say something like this. Then of course we have another line here. Maybe let's cross it here. Then maybe let's say we have our R here. Then we can say we have our angle beta here. Then of course this is the point where we have 0:4, right? And of course here we have our angle 56,31 degrees. And of course here we have our point Q, which is your 9:9. Okay, so from that point now we can see that we can be able to get this specific value beta in two different ways. Okay, which when we add beta plus 45, we can get, if we add this angle plus this 45 which we have here, this will give you this external angle, right? If you still remember external angle, so that's why I initially subtracted. That's the first scenario. The second scenario now, which means it's gonna be inverse to what we are speaking about as well. So that will now be something like your, again, something like this. Then again passes from point there, then of course something coming from point Q over there. Of course they still need to pass through the point R, so this is your point R there. So you can see that this, if this is your 45 and this is your 56,31 degrees, now we can at least be able to calculate. Okay, this is a bit close to each other. Let's see if we cannot write something like this. Yeah, then have another point so that at least people can be able to see what I'm talking about. Okay, so this is the point which is 45 degrees, then this is your point which is your 56,31. Okay, so this is maybe our beta there on top there. So we can now be able to find that beta easily because we know, and how to calculate that is quite easy. So that's why I did that. So these are sort of like two schematic diagrams perhaps we should at least remember when we are solving our problem tomorrow. All right, so that's just a couple of questions they want us to have, so that at least we can be able to work with them. All right, now question 4. All right, question 4, so that we can proceed and get the job done. All right, in the diagram, the equation of the circle, okay, let's underline that. This is circle geometry. The equation of the circle centered at B. Oh, okay, so this equation of this circle is for this specific one, which is centered at the point B. Oh, okay, it's fine. It's given by x plus 1 squared plus that. Okay, so this is what we have, which means already we can now see the coordinates of B, because we already know the equation of that, and we know that it's 1:2, so it's going to be 1:2 that. Okay, check. DF is the tangent. This is a beautiful word, so we need to underline that, to the circle at center A. Okay, at A, and DF and the x-intercepts respectively, where C is given as that is a point on DF with BC parallel to the y-axis. Okay, this one BC. Okay, BC, which means BC is parallel to the y-axis, and this is our y-axis, and we are given that AD0 or ADO is ADO. Okay, it's angle theta. Okay, cool. Write down the coordinates of B. Guys, we are just copying those equations as they are. We are taking them here. So this is positive, so this will be -1 is to this is positive, so that will be negative over here. This was negative, so that's just that. So the coordinates of point B is the center, which is at -1 is to 1. We took them from the equation which we are given here. All right, so we can see that from the equation which we are having here. You can see that this is your +1, so that will be -1. This one will be +1, so that will be your coordinates of B. Second question, show that AC is equal to square root of 5. How can we show that AC? Where is AC? AC is the line from here to here. Show that AC is equal to square root of 5. How can we show that? Which means we need to be able to calculate that quick and fast. We can see that our BC can be equal to your 6 minus 1, is it? Let's check. point C is given as -1 is to 6. Okay, so that's point C, which is -1 is to 6. So we can be able to find, and we can be able to see that, okay, the length of BC, from what we are seeing here, your BC can be equal to 5 over there. Okay, so BC is equal to 6 minus 1. Okay, we can see that BC will be equal to 6 minus 1. Okay, because you can see that from here to here it's given already as that positive 6 here, but from B, the center here going there, we can see that it's going to give us that -1 which we had. So that's why it's 6 minus 1, which is now giving us 5. Now we can now see that our AB is equal to square root of 20. It's stuff, right? Why is it 20? Because we can see this is what we have, which is the r squared, which means if we want r, we just have to square that. Okay, so that we can be able to get r. So we can now see that our r there, which is the radius, is square root of 20. And we also know that the angle CA and D, C, A and B, sorry, not D, C, A, this is 90 degrees. Why? Because we know that this is tan perpendicular to the chord. Okay, so Euclidean geometry is already playing into place already here. So now we can now be able to see that your AC now will be equal to square root of 5. How are we going to get square root of 5? Because we know that AC by Pythagoras theorem, okay, this is going to be AC squared is equal to your 5 squared, which is BC squared, plus your AB squared. Okay, why? Because we are using Pythagoras. So we need to have that in mind. So from that point now, we can now see that your AC, which they want, will be AC equal to square root of 5 squared, or BC is 5, plus negative square root of, oh, what am I doing? Okay, so AC will be minus, because AB was the other part, which is quite big. So that's minus square root of 20. We square that. Then, of course, here again, it's minus that. Okay, cool. Then now we can see that our AC, with us using our calculator, this would be just square root of 5. That's how you do it. Let me repeat this one. So we can see that you are given the coordinates of point C over there, which is -1 is to 6. So we can now find the length between B and C, and our BC was 6 minus 1, which is equal to 5. Then from that point, 6 minus 1 is equal to 5. Then from that point now, we can now be able to find that, and we can see that this is 90 degrees because it's tangent. This is the tangent which we are looking at, which is perpendicular to this specific radii there. So which means this is 90 degrees. So we now also know the length between A and B, because we know that this is square root of 20. Now we can now be able to find the missing side AC, because AC will be this BC minus this A squared, because it's Pythagoras theorem, and BC is your hypotenuse, right? This is your hypotenuse, and this is just your other side, adjacent side. This is your opposite side. So you can be able to use that, and you can be able to get the answer over there. All right, so we're able to show that on the value of theta, tan theta. Okay, let's check that. So we can use that using different angles. So here's the value of tan theta. Tan theta should be EFO over OD. Okay, so we can see that also tan theta, oh, this is theta, so there are two thetas, so since these two angles are equal to each other, we can see that our tan theta is equal to your AC over your AB, right? Because this is easy, your AC over your AB, because this is the opposite side. This is 90 degrees, remember? So this will be from here to here, which is your AC over your AB, opposite over your adjacent side. So this is the how we can be able to critically analyze that. So what is your AC? Your AC is given as square root of 5. What is your AB? Your AB is your square root of 20. So this will be divided each other. Then using your calculator, I'm getting 1 over 2. So please also use your calculator so that at least you can be able to get the values of that specific function which we are playing around with. So tan theta is equal to that. Okay, this is a bit challenging, but okay, what do? We solve, and we soldier on. Now show that the equation of AB is given by y is equal to that. Okay, how many marks is that? So that we can be able to show them that we know what we're talking about. 4.4, we're looking at 3 marks. So we need to show that that is equal to that. So how can we solve that? We can solve that fast and quick, because we know that from the above, we already know that tan theta. We already know that tan theta is equal to 1 over 2. We've solved that, and we know that the gradient of DC multiplied by the gradient of AB should always be equal to negative 1. Why? Because we know that these two perpendicular to each other, so the gradient of this and the gradient of DC, as you can see here, should be giving us negative 1 because they are perpendicular, bisecting with each other. And bear in mind, this is 90 degrees. So this is the gradient I'm talking about. The gradient of MAB times the gradient of DC should be equal to negative 1 because they are perpendicular to each other. So now we can now be able to play around with what we have, and we can see that the gradient of DC there will be equal to tan theta, which is equal to 1 over 2, because we can see that that's where this angle, when you're having that angle there, it's subtended angle theta on the x-axis. So that's where we can get that 1 over 2 for the gradient of DC. So which means from that point now we can now be able to solve our stuff quick and fast, because we already know what we are dealing with. All right, so which means from this equation which we have formulated for ourselves, so which means we can now have 1 over 2 times gradient of AB, which is equal to negative 1. Then of course from that point the gradient of AB now will be equal to negative 1 over 2, which is just going to be equal to your negative 2. Easy stuff. Then from that point now we know that our equation is y minus y1 equal to mx minus x1. Then of course after that we can now be able to substitute the point B, which is negative 1, is to 1, because that's the point which we have at point B at the center. So that will be y minus 1 equal to your gradient, which is negative 2, x minus your y1, which is again negative 1 here. Then now we have y equal to negative 2, x, this is going to give us a positive, but that will give us negative 2 plus 1. Then now we end up having your, therefore your y is equal to negative 2x, 1 minus 2 is negative 1. So this will be our gradient over there. It was a beautiful question. I believe it was quite an eye-opener over there. Okay, 3 marks over there. Then we still have these 2 to get. This other one is 4 marks. Okay, determine the coordinates of A. Where is A? Let's look for A. So our A is here, okay, and we know the equation of the line AB. So now they want us to calculate and find this specific nice question and find the coordinates of A. This is easy, guys, because we can already see how to do that, and there is only 1 or 2 ways in which you can solve that. And the first one is to understand the equation which we are given, because we can see that it's being just derived on just small occasions. So this can be option 1. So of course we know that this is x plus 1, which is squared, of course, plus this is the equation which already been given. So plus you have your negative 2x now minus 1 squared equal to 20. And you know where this negative 2x minus 1 is coming from. Where is it coming from? Everyone know where it's coming from, because you have calculated that equation of to be y equal to negative 2x minus 1. So our y now is now negative 2x minus 1 squared equal to 20. And this equation is originally given to us, as you can see here, that x plus this is equal to this. So this is our original equation. But now that we know that specific now, and we can now see that our y was even negative 2x minus 1. So this will now be your negative 2x minus 1 minus 1. So that's what we just did here in that question. So now we can now see in solving it further. So that will be your x plus 1 squared plus your negative 2x minus 2 squared equal to 20. Then of course after this we now have to play around with what we have and get the answer over there. So we know that x plus 1 times x plus 1, that will be x plus 1 squared. So x times x is x squared plus your x plus 1. So that will be x squared plus 2x plus 1 plus, then for this part here, that will give us your positive, that will now be your negative 2x minus 2 multiplied by negative 2x minus 2. So that will be negative 2x, that's positive 4x squared, positive 4x, positive 4. Wow, beautiful. So that will be 4x squared plus 8x plus 4 equal to 20. Then of course we can rub that out. So now that will be your x squared plus 4x squared, that's your 5x squared. 2x plus that will give us your 10x. 1 plus 4, that will give us positive 5 equal to 20 over there. Then of course we know that this will now be the same as 5x squared plus 10x. 5 minus 20, that will be negative 15 equal to 0. Then now we have that. Then if you can put 5 in all of them, that will be x squared plus 2x minus 3 equal to 0 if we divide all through by 5. Then from there we can now have our factors. 2 factors equal to 0. So x and x, this is negative 3 to get 2. We need to have 3 positive and 1 negative over there. So I can be able to get the middle term. But if you are here and you don't know how to find factors as what I did here, please use your quadratic equation, which says that x is equal to negative b plus or minus square root of b squared minus 4ac over 2a. It's always there for you. It's always there to save the day for you. So that will be x plus 3 multiplied by x minus 1 equal to 0. Okay. Then that will be x is equal to negative 3 or your x is equal to 1. All right. So now we have 2 values of x. And of course, from there, we know that our equation is y equal to negative 2x minus 1. So if we can substitute negative 3 over there, that will be y equal to negative 2 multiplied by 3 minus 1. So that your y will be now be equal to negative 2 times negative 3. That's positive 6. 6 minus 1 is 5. So our coordinates of point A will be negative 3 is to 5. Because already we can see where our coordinate or where our A was. Can see our a is in the negative side. So on the two values which we got negative 3 and positive 1. So there is no way this point A was going to be positive 1 since it's in the second quadrant and it's on the negative side. It had to be that negative 3. So we had to substitute that into the equation which we had received over there. All right, let's look at trigonometry now. Question 5, trigonometry, which means you're done with the first 40 marks. Now let's look at the other 40 marks which will be in the exam tomorrow, so that at least people can be able to pass and get the marks from this specific section, which is trigonometry. Okay, simplify. So the moment you start solving for trigonometry tomorrow, guys, please do me a favor and yourself a favor. Please make sure that you use your cross. Okay, that's the first thing you need to draw there. Here is your cross. So we can see that all students take coffee. 0, 90, 180, 270, 360. Then we can include a different marker there. So this is your 90 minus, this is your 90 plus, this is your 180 minus 180 degrees plus. Don't use 270. Then we have 360 degrees minus, then we have 360 degrees plus. So that can be able to do proper reduction over there in that specific question which we have. Right. So sine squared of 180 plus x times sine times negative x divided by that to a single trigonometric ratio. Okay, that's easy. 180 plus is in the third quadrant, which means our answer there will be negative sine, okay, of x. Then of course we square that times negative sine x is just going to be negative sine of x, guys. It doesn't change. The sine of a negative angle is always going to be negative. The 90 plus is in the second quadrant and sine is positive, but this is sine at 90, which means it's going to give us a co-ratio, which is negative cos of x times your tan of x, and tan of x is an identity, which is sine of x over cos of x. So that will be times sine of x over cos of x. Then of course we subtract that 1 there. Then from that point our life is already easy. How is it easy? Because we can see that this and this will now cancel each other. Let me not do that cancelling. Let me use this blue. You can see this and this cancel each other. So now we now have what we have. Okay, so this negative x and that will also cancel with each other as well, right? This here and this will cancel with each other. Then now we are only left with negative sine of x squared minus 1, which is the same as sine squared of x minus 1. Then of course this is just where you can get. Of course you guys are smart. We know that cos squared of x plus sine squared of x is equal to 1. So of course we can now change that and make it more nice and more interesting. Okay, so we can see that this can be your sine squared of x minus, then in the position of 1 you can have your cos squared of x plus your sine squared of x. Then that will be sine squared of x minus cos squared of x minus sine squared of x. Then of course, then from that point we can see that because they said to a single, so we need to leave 1. So this and this will cancel. Then now we are only left with negative cos squared of x, since they say that to a single trigonometric ratio. So we end up having only negative cos squared of x as our single trigonometric ratio. Easy, just like that. Okay, given that cos A minus B is equal to cos A. Oh, identity, compound identity. So cos A minus is always that. Okay, now use the above identity to deduce that sine A plus B is equal to that. Ah, guys, this is easy, guys. Why is it easy? Because we know that sine of A plus B is always equal to easy stuff. Okay, this is the same as your cos of 90 degrees minus your A plus B, because we know that when you multiply, subtract 90 minus, that's a co-ratio. So we solve this or prove this using a co-ratio. So this will now give us now cos of, then we can now have 90 degrees minus A, and of course minus your B over there. Then of course from that point now we can now end up having your cos of 90 degrees minus A times your cos of negative B, or sorry, cos of B negative, and that will be positive, sine of 90 degrees minus your A times sine of B, applying that identity over there. So this will now be sine of A times cos of B plus cos of A times sine of B, because this is also again an identity. All right, so this again we use the co-ratio part here as well. We use the co-ratio, then we can be able to solve the problem which we have. All right, okay, now simplify without using a calculator. 420 15 sine cos. Okay, that can work. It's an interesting one as well, but let's see how we can solve that. So this can be the same as cos of let's see, 360 degrees plus 260. It's going to give us 420 times cos of 15 degrees plus sine of 360 degrees minus 60 degrees times cos of 90 degrees plus 15 degrees over there. Okay, 105 is 90 plus 15. So this will give us cos of 60 degrees times cos of 15. Wow. Plus, okay, this is not going to be plus, this is going to be negative, sine of 60 degrees times your cos there, that will change to sine, but this sine should be negative because it's at 90 plus, so that will be negative sine of 15 degrees. So now that will give us your cos of 60 degrees times cos of 15 degrees plus negative times negative is going to be positive, so that will be positive sine of 60 degrees times sine of 15 degrees. So now we can see that it's cos cos sine sine. So this is the same as cos, and it's positive here, so which means it's going to be cos of 60 degrees minus your 15 degrees over there. Then I end up having cos of 45 degrees, and they say that without using a calculator, which means you can now use your special triangles. This is your special triangle for 45. What's happening with Uyoni? Here we go. Okay, so this is your 90, this is your 45, this is your 45, this is your square root of 2, this is your 1 1. So this will be equivalent to 1 over square root of 2, or it's just square root of 2 over 2. But this one shows that you've used your calculator, but I think lately they are marking that as well. You can just use one of the two. These two are equivalent to each other. All right, 5.3, or we're given tan squared of x over 1 over tan squared of x. Okay, minus 1. Okay, interesting. Prove that tan squared of x multiplied by that is equal to that. Oh, okay, how do we prove that, guys? So we can prove on the left hand side. So we start by saying left hand side. Let's use the red again. Okay, left hand side is equal to your tan squared of x multiplied by 1 over tan squared of x minus 1, and this is equivalent to your tan squared times that will be tan squared of x multiplied by 1 over tan squared of x minus your tan squared of x. This and this will cancel, then we have 1 minus tan squared of x, and this now, this will make our life easy because 1 minus now sine squared of x identity over cos squared of x. There is another identity which we can have over there. Then from that point now we can now see that if we can make cos squared of x the subject there, that will give us cos squared of x minus the sine squared of x over there. Okay, and we know that cos squared of x minus sine squared of x is an identity there, which is the same as cos of 2x over cos squared of x, because this is just a double angle. Okay, that's easy, guys. So we're able to prove that the left hand side is equal to the right hand side. So usually when you're proving, take the hardest side and prove the hardest side, because the hardest side is the way you'll be able to get more points to solve your question. Okay, 5.32. Now, for what values of x is in the interval of 0 and 90, this is going to be undefined. Definitely, tan is not defined at x is equal to 90, guys. We haven't asymptoted that specific value, so definitely there's no way it's going to be defined on that point. Now determine the general solution of the equation. Guys, general solutions are the easiest ones. So we're given cos 2x equal to cos, so that can be the same as cos of 2x equal to cos of x. And you know this is the double angle, so we can change it to 2 cos squared of x minus 1 minus cos of x is equal to 0. And of course that will be 2 cos squared of x minus cos of x minus 1 equal to 0. This is just already an equation, guys. So you can see that this will now give us a quadratic equation. So this will now be the same as your 2x. Okay, so otherwise you can say let your cos x be equal to x, so that at least you will still remember. So this is the same as 2x squared minus x minus 1, which is equal. So this is just the same. Okay, if you don't know how to play around with the trig ratios, just use your x there, so that at least you can be able to substitute there and get proper answer. So that will now give us your 2 cos of x plus 1. Another one there, when we're finding factor, that will be cos of x minus 1 equal to 0. So your cos of x now will now be equal to negative 1 over 2, or your cos of x, which is equal to positive 1 over there. Okay, then from there now we can now be able to solve our problem which we have at hand and get the general solution which we wanted. So cos of x equal to negative 1 over 2, using your calculator, that will be 60. So that will just give us that, and you can now say that your first general solution there can be x is equal to 180 degrees minus 60 degrees, okay, plus your k, 360 degrees for the k value. Of course your k should be the element of the integers, or okay, 180 minus 60, that's what, 120. So then your x will be equal to 120 degrees minus your, or plus your 360 degrees of k. Easy stuff. Again, when we are using the other one, again, that will give you your positive 1 there, which is going to give you 60 as well. So this can also have an or, and you can have your x is equal to 180 degrees plus your 60 degrees plus your 360 degrees of k, where k is the element of the integers. Then from that point, of course, your x will be equal to 240 degrees plus your 360 degrees of k. Okay, then of course your k still should be the element of integers. Guys, come on. Okay, now given that sine theta is equal to 1 over 2, oh, okay, so what? Calculate the numeric value of sine 3 theta without using a calculator. Guys, this is easy, because we know that sine of 3 theta is the same as sine of 2 theta plus theta, right? So now we can now apply the compound identities. Minus plus cos of 2 theta times sine of theta. Sine of theta, already know what sine of theta, right? So our life is already more easier there. But we know sine 2 theta is the same as 2 sine theta times cos of theta times cos of theta plus cos 2 theta. There we can change it in terms of sine. That can be 1 minus 2 sine squared of theta times sine of theta. So this now can now give us, so equal to your 2 sine of theta times cos squared of theta plus sine of theta minus your 2 sine cubed of theta equal to 2 sine of theta. Then that can be 1 minus sine squared of theta. To change this cos squared of theta, we can change that to be your 1 minus sine squared of theta, plus we can now have your sine theta minus 2 sine cubed of theta That will now be your 2 sine of theta minus your 2 sine squared of theta plus sine of theta minus 2 sine cubed of theta. This will now be equal to 2 sine theta plus sine theta. That is going to give us a positive 3 sine of theta, negative 2 sine, or this is going to be sine cubed minus that, so that will give us minus 4 sine cubed of theta. Then this will now be the same as your sine theta is 1 over 2 to the power 3, because then you can now use your calculator to get the correct answer over there. Okay, so your life already is easy, guys, so don't worry a lot, guys, and this is just the same as your 1. Okay, alternatively, you could have just calculated the angle theta. Theta is just equal to your arc sine of 1 over 2, then your theta is just equal to your 30 degrees. So now sine of 3 theta will just be equal to your sine of 3 times 30 degrees. 3 times 3 is 90, so that will be sine of 90, and sine of 90 is just equal to 1. So you could have used the hard way or the softer or easier way. Both style was going to work. Okay. In the diagram below, the graph of f of x is equal to that. Okay, is drawn for the interval. All right, now on the grid, draw the graph of g of x is equal to negative 2 cos, and that, guys, this is easy questions. We're gonna use our calculators to do that. So when you draw with your calculator, you're gonna see it's gonna be something which is starting somewhere here, then at 0 is gonna be somewhere here, so it's gonna be something like this. So this is not hard. We just use our calculators over there, guys. So please make sure that you use your calculator, guys, so that at least you can be able to get the values which we want. Negative 1 there, at 45 it would be 0, then there it goes to 1, at 90 it's 1, then again it's 135 is 0, then at 180 it's so it's something like this, guys. So this is going to be your function. Please just use your calculator. That's straightforward, guys. No, that's straightforward. You're just using your calculator to do that. Okay, write down the period of the function 2gx plus 10. What is g of x? This is g of x, so they're saying that it's 2g of x plus 10. Oh, okay, no, guys, the period is still going to be just your 180 degrees. Use the functions or the graphs to find the values of x in this interval between 0 to 180, for which f of x times g of x is less or equal to 0, which means we are looking for where these two functions, when you multiply them, they are just less than 0. We can see that between 0 and 45, this one is positive, this one is negative, so this is going to be negative. And also between 90 and 35, you can see this one is going negative, this one is going to be positive. So the interval will be at x element between 0 and 40. You need to just understand when it's less than. When is it less than? It's only less than when it's negative. So another one should be positive, another one should be negative. Also an x element between 90 degrees to 135. Okay. Then from that, you can be able to get the answer. 6.4, write down the maximum value of f of x minus g of x. Guys, so we know that this will be your f of x minus your g of x. Your maximum value of f of x is 2. So that will be just 2 minus your maximum of g of x. I'm sure you see your maximum value, which we have there. And your maximum for that is going to be 1 over this. That will be negative 1. That will just give you positive 3. So that will be the maximum value between the two functions. Guys, easy stuff. Determine the range of this function y equal to 2 cos of x plus 2. So the range of this function is not bad, but we just need to know where can you find and get this answer which we are looking for. So this is for you guys to try it out on your own as a homework, then send the answers in the group, okay? Because I know the answer, but I want you also to do something and get your hands dirty there. But of course, what is maths without this question, which is usually asked for you to apply your 2D and 3D over there? This is one of the questions which is quite critical in your school, because you are now applying what you did in grade 11, your sine rule, your cosine rule, and your area rule. So in the diagram below, it shows two vertices, pose AD and BC. Point E lies on the same horizontal plane as bases D and C. D and C. Okay, we see that, and we can see that we are also given the pause at AD, which is equal to BC. Okay, we see you. We are given AEB is 2 alpha. AEB, you can see that. Given that one, which is equal to alpha, we see that as well. Given the 90 degrees minus 3a, we see that. We also see that by is with respect to y meters. That's easy. Determine b with respect to alpha and y. Where is b? BE. BE is this hypotenuse side, and they want this to be represented to a and y. We can see that y already is for this specific thing, and we already guys, easy stuff. We know that sine of alpha will be equal to y over BE, because y is the opposite side and B is the hypotenuse. So BE now will end up just being your y over sine of alpha. That one is not bad. That's easy. I'm sure everyone can be able to solve that. Straightforward. 7.2, show that AB is equal to 2y. Okay, how can we show that AB is equal to 2y? What is AB, or where is AB? Here is your AB, right? This is your AB. So they want us to show that it's equal to 2y, which means we need to have this y integrated into that. So how can we solve that, guys? So in my mind, I'm thinking of two things, all right, so that can be able to solve that. So if we can look at the triangle ABE, if we can look at this triangle ABE, we can see that this BE already, we know already the equation of this line BE. So if we look at this line and we already know that, we can now have that AE over there. So we can also see that your BAE there is just going to be easy. You can be able to find this angle, because we know that this will now just be your 90 degrees minus, let's say this is x. So if we say the sum of all the angles in the triangle, so that will be x plus your 90 degrees minus 3 alpha plus your 2 alpha is got 180 degrees, sum of angles in the triangle. So that will be x plus 90 degrees 2 minus 3a, that will be negative a. Yes, you got 180, so your x will just be equal to 90 degrees plus alpha. Okay, because 180 minus 90 is equal, so this angle x here will be 90 degrees plus alpha. So we have that angle. So now our life should be easy, because when we are playing around with this, we already know that this is the triangle we are playing with. So we know this angle, so this angle is parallel to this side. Then of course we can now be able to find that, and they say that show that AB, so which means we also have this side, which means we can use your area rule. Perfecto. So we can just now write it that so that people can see that. So we can say that in triangle ABE, right? Triangle ABE, we can see that our BAE will be equal to your 90 degrees plus alpha, sum angles of the triangle as I showed you above. Then from that, now we can now be able to solve that, because we know that your AB over your sine of 2 alpha for that angle there, which we have as I showed you here, right? So AB is this side and it's opposite to this specific angle which we have here, okay, 2a. So that's why it's like that. Same applies with this angle which you calculated, it's opposite to this one. So our lives will be already easy, right? Because life is beautiful. So using the sine rule in this instance, this will now be equal to your BE over sine of 90 degrees plus your alpha. So now your AB will be equal to your BE multiplied by your sine 2 alpha divided by sine 90 plus is just equal to cos of alpha, because at 90 degrees sine and cos changes. So your AB here will now be equal to your BE, and your BE we calculated it's y over sine 2a multiplied by sine of 2a, then we divide all through by and we know that it's sine a, not 2a. Sine a times sine 2a is a double angle, which is 2 sine of a times cos of a, then we divide all through by cos of a. So we can see this and this will cancel. Now we have AB, which is equal to 2y cos of a alpha divided by cos of alpha. So this and this cancels. Then we can now see that your AB is equal to 2y. Easy stuff. So we just have to know that usually in many instances we need to use the sine rule. If it is given that AF is equal to 4 over that, now determine the angle. Guys, this is easy, right? Because now we already solved it through the equations which we already have. So we can now see that if we can look in this triangle, if we look at this triangle BAF, as you can see, this is your B, this is your A, this is your F, okay? Let's just clean this so that people can see what we're talking about. So if we can look at this triangle B, A, and F. Now we can now see that if we look at this triangle, we can now see that cos of B, A, F will be equal to your AF over AB. Over AB, and this will now be your 7y over 4 divided by 2y, which is just the same as 7 over 8. That is not bad, guys. Come on. So now then, therefore, we can now be able to find BAF, because now we know that BAF here will just be equal to your cos of 7 over 8. Then you use your calculator to get the angle. Guys, come on, guys, come on now. This is not bad. Now let's just do 1 or 2 questions on Euclidean geometry, so that at least we can have nice time tomorrow when we write. Okay. In the diagram below, the circle passes through points A, B, C, and D. All right, circle. Okay, we see that. We see you, G. Can see that, yes. Now, AD is the diameter. Oh, my word. AD is the diameter. What does this mean? Which means that we can subtend the 90 degrees angle. Of course, this angle already is 90 degrees. Okay, I'm not saying anything because we can hold angle AD. But now, let's see if we have a center so that we can be able to see. And we also give them that BD and AC intersect at H. Okay, we can see that they intersect at this point here, and AGC is 58. Where is AGC? Okay, this is 58. So if we hold that chord, that chord is going AB, it goes to angle D, but doesn't go anywhere. If we hold that chord here, this can go that side, but it cannot subtend. Okay, so there's no angles on the same segment in this question. Okay, cool. It's fine, I don't mind. Now they say that find the angle B2. B2, guys, is equal to 90 degrees. As I said, why? Because we are given the diameter over there. So B2 is equal to 90 degrees. Y angle in semicircle. That was straightforward. Now they say that find angle B1, 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 B1. So we know angle B now, the one B1. So we can see that if we can have B1 plus angle B2, okay, plus angle G. Oh yeah, but guys, do you guys see that we have this beautiful cyclic chord? Yebo. Isn't that a trend? Okay, so we can see that this is a cyclic chord over there. Okay, then I'm sure we can solve that first. Because we know that that's a cyclic chord. So since that's a cyclic chord, so we can now get the opposite side. So if we can say this angle plus this angle equal to 180, so that if we say B1 plus B2 plus 58 degrees is equal to 180 degrees. Reason why? Opposite angles of a cyclic chord. Okay, then now we can now see that your B1, which they want, will now be equal to 180 degrees minus your 58 degrees minus your 90 degrees, which is B2 over there. Then you get your B1, which is just equal to 32 degrees. Easy stuff. All right, great. Now they want you to find A2. Where is A2? A2, they want this angle of A2. How can you find angle A2? Let's see A2. Okay, if we code DC goes to A2. Let's use red there. If we hold this chord DC, it goes and subtend to angle A, and it comes back again here, right? Then again, that same chord goes and subtend at B1, and it also comes back to the same chord DC. So then, therefore, we can now see that A2 is equal to angle B1 which is equal to 32 degrees. Why? It's angles in the same segment. That's angles in the same segment over there. All right, so don't worry, that's not bad. Then what else are we given to solve? Okay, if it is given that AB is equal to BC, prove that AB is the tangent to the circle passing through point A, H, and D. If given that AB is equal to BC, where is AB? So it means they're saying that AB, let's use green. If they say that AB is equal to BC, it is given that. Now we need to prove the part for the turn code. So that's easy, guys, because if that's given to each other, which means we can see that C1 is equal to A3. Okay, C1 is equal to A3, guys, and that can be just equal to your 29 degrees, because we know that 58, this whole angle 52, 58, it's that. So if we subtract that, we're gonna get, and we divide that 2, because these two are equal to each other. Why? Because we know that angles opposite equal sides. Then from that, we can now see that your angle D will be called angle C1, right? Why? Because we know that these are angles in same segment. Then from that point now, we can now be able to be happy, because we know that A3 is equal to D. They are all equal to 29 degrees. Then from that, so we can now then conclude that AB is a tangent. Why? Converse turn chord. So every time you prove the turn chord, or if say prove that this is a turn chord or anything, you prove using the converse of it. Anything you prove with the converse. Let's see if we can be able to, guys, proving this is just easy stuff. Everyone should be able to prove this. You should be able to memorize this by heart and prove that. The first thing we construct, here we go. Of course, we join that. So guys, please go and look into, this is the theorem number 2 when we are looking at this. So please, guys, just go and look into this again and again. This is a theorem which is very critical and very important. As you can see here, it's the one for the tangent. I think it's theorem 6 or 5. So please go and look into that, so that at least you can be able to prove. You need to just know how to prove by your head and your heart. Let's see if we don't have a hard question here. Also, let's do the last question, which is question 9 over here, so that we can be able to solve it and see if people at least are happy with it. Okay, let's do question 9. That will be the last question for the day. Okay, in the diagram below, D, E, and F are points on the circle centered at Q. Okay, this is the center Q. Okay, AGF is a tangent to the circle at F, AGF. Okay, let's just put these tangents in green so that we don't forget that these are actually tangents. They end here. So this is another tangent, and also they say that ED is produced to meet at the tangent at A. ED is produced to meet at the tangent at A. Oh, okay, interesting. And of course, they are also saying that B and C are points on AE, and GB is parallel to FD. Okay, GB. Okay, I see that one. Yeah, GB is parallel to ED. To FDS, and GC is joined. Okay, so GC is just joined. All right, GCDF is a cyclic quad. GCDF is cyclic quad, and FQD is 2x. Okay, cool. Now, first question, give a reason why angle E is equal to x. Guys, angles at the center is equal to twice the angles at the circumference. So that's why that angle is equal to x. So we can just say that angle at the center is equal to 2 times angle at the circum. Okay, so that's not bad. I'm sure everyone can still realize that one. It's not bad. Angle at the center, that's why, because this is 2x, so this is definitely going to be x. Okay. Now, second question, prove that GC is parallel to FE. GC, prove that this is parallel to FE. FE, okay, prove that these two are equal or parallel to each other. If we can be able to prove that C1 is equal to angle E, we can use corresponding angles. So in order for you to prove something that is got or whatever that is, you need to know what is the characteristic of what you are dealing with. So in this instance, we are looking at the characteristics of this specific shape. And now the characteristics of this is that when you're looking for parallel lines, you need to look for alternating angles, corresponding angles, and all that kind of stuff. So we can now see that angle F1 is equal to S, right? F1 is equal to XY because this is your tan chord theorem. Then of course we can now see that C1 here will be equal to angle F1, which is also equal to XY because it's the exterior angle of the cyclic quad, because they told us this is a cyclic quad, guys, so we can use that to advantage. So this will be an external angle for the cyclic quad. This is the cyclic quad they told us here. This is their cyclic quad here. Here we go. This is their cyclic quad they told us. So we can see that equal to X as well because they are just exterior angle of the cyclic quad. So then you can see that C1 is equal to this, which means they are corresponding angles. So we can now therefore C1 is equal to angle F1 E, sorry, this angle E here, which we are given here. Why? Because we know that they are equivalent to each other. All right, so then therefore now we can now conclude and say that GC is parallel to FE. Why are they parallel? Now you can just say corresponding angles are equal, because that's how we prove it. We prove it using the corresponding angle. So the corresponding angles are equal. Now prove that AB over BD is equal to AC over that. Okay, that's not bad because we already proved some interesting things about parallel lines. So we can use prop theorem and you can see that AB over BD is equal to AG over the GFY, because we can now say that we can have the prop theorem. And what does the prop theorem say? It needs you to state the parallel lines, and you can see that GB is parallel to FD, guys. Okay, GD is parallel to FE. All right, so our life GB is parallel to FD, so we can already see that our life is already easy. So that's why I'm saying that your AB over BD is equal to your AG over GF because of the parallel line. So AB over BD is equal to AG over that over there. And of course we can see that something is very important also. We can also see that if we can look at that bigger triangle, because we also proved that this is parallel to that as well. So we can see that your AD, your AG, you can also see that your AG, this AG over your GF is also equal to your AC. Okay, AC, as you can see here, because now we're looking at this new parallel lines which we have proved. So AC over your CE. Again, we can just say prop theorem. Why is it prop theorem? Because we have proven that GC is parallel to FE. So now we can already see that everything is both equal to AG over GC. So which means that AB, okay, so we can see that this, everything, even that other one is equal to that. So we can now see that AB over BD will now be equal to your AC over your CE. Why? Because they are both equal to your AG over GF. Just using prop theorem. Now, last question, determine if it's further given that AB is 12 units and C is equal to 22,5. Now they want you to find the length of CD. Guys, this is easy. So we're given that we know that AB over your BD will be just 4 over 5, right? Because we can see that this AG over GF will be equal to 4 over 5 right now. So, and we know that AB over BD is equal to AG over GF. So we can now say that AB over BD is equal to 5 over there. And after that, we can also see that we can now be able to calculate the angle or the side BD, because already AB is 12. So that will be 12 over your BD equal to that ratio, which is 4 over 5. Then now from that point now, you can calculate BD, because BD now will be equal to 12 times 5, which is 60. So that will be 12 times 5, which is equal to 60. We divide that by 4, then that will just give you your 15, because 60 divided by 4 is 15. So then therefore now we can now see our BD is equal to to 15. The question, again, we can also do the same thing. AC over CE is equal to 4 over 5, because we already know that AC over CE is also equal to your AG over your GF, which is also equal to 4 over 5. Then now we can now do the calculation as well. AC over 22,5 is equal to 4 over 5. Then your AC now will be equal to 22,5 times 4 divided by 5. That should give you just 18 over there. So now we have AC and BD. Then therefore we can now see that BC is your AC minus your AB. So that will now be equal to your 18 minus 12, which is equal to 6. Okay, then from that point we have 6 units there. Then of course CD, the one which we want is BD minus your BC. So that will be BD, which is your 15 minus 6. Then you give your 9 units over there. So we were looking for CD, and CD is just equal to 9 units. So this is us just trying to see if we can be able to solve and prepare for you guys for tomorrow. So we've done trig, we've done analytical, we also did Euclidean geometry. We just didn't do statistics because statistics is always easy. If you need the question paper, just text here on the comment section. Then I'll also send you the question paper for you. If you have more questions, make sure that you're in the WhatsApp group for YeboTutor, so that we can be able to give you the questions which we have covered today in today's session and prep for you. Okay, from YeboTutor to you guys, have a beautiful evening, and I hope you enjoyed. Any question or any further questions you guys have, please make sure that you ask the questions in the group, WhatsApp group. Join through the description of this video. Cheers, all the best for tomorrow.